Good afternoon, students. We are going to add 264-bit numbers using ARM7. You can see 264-bit numbers. These are the 264-bit numbers which we are going to add. The first number is assigned to variable value 1 and the second number is assigned to value 2. The entire number is divided into two parts, 32-bit and 32-bit. This is because in ARM7 each register is of 32-bit long. So the entire number is divided into two parts. Now the first part will be stored in register R1. The second part will be stored in register R2. Similarly with the second number, the first part will be stored in R3 and the second part will be stored in R4. The logic is the content of R2 and the content of R4 get added and the result will be stored in R6. Similarly, the content of R1 and the content of R3 will be added but along with carry. In previous operation, if the carry is generated, then that care should be taken. So here we are going to use add with carry instruction and the result is stored in register R5. Let us see the step-by-step execution of this. Let us see the step-by-step execution of this program. Create a folder, say lab1. So I have created one folder, lab1 on the desktop. Write your program in Notepad. Save that program with .asm extension. I'll explain this program. You can see here LDR R0 is equal to value 1. So value 1 is the variable where the first number is stored, first 64-bit number is stored. For us it is value 1, but for machine it will be a memory location and the address is assigned to this value 1. Now with the help of this instruction, the address is captured in register R0. With the help of this instruction, the number which is stored at memory location R0 is copied to register R1. So this entire number will get copied into register R1. So now the second part of this entire number, this one, is copied to register R2. Here we can see that R0 comma #4. It says that increment the memory location by 4. So now the memory address is R0 plus 4. So the content of memory location pointed by address R0 plus 4 gets copied to register R2. Similarly with R3 and similarly with R4. Now content of R2 added with content of R4 and the result is stored in R6 as mentioned earlier. Similarly, the content of R1 and R3 added together and the result will be in R5. Let us see the step-by-step execution. Okay, so the first step done. Now second step, open kill 5. So open kill 5. So project, new project. Okay, so now you can give any name. I'll give name ABC. Save. Then type LPC2148. Okay, select LPC2148. LPC2148 is an ARM7 IC. You can read the information here from here. Okay, now say no to this. Okay, so now click on target source, click on source group, right click on source group, add existing files to. Okay, now we want to add .asm file, so that file types will be all files and okay, add, close. So add 64-bit.asm is added. Now as per this document, okay, so we have added, okay. Now the 12th step is right click on add 64-bit.asm file and click build target. So right click, build target. Okay, here you can see 0 errors, 0 warnings. After that go to debug, start, say okay, yes. Now this is your program. Here you can see the step-by-step execution of the program. Students, now we will see the execution of the program. Now here you can see these are the registers of ARM7. Now you can see that initially the contents of all registers are 0. Now we'll execute step by step. For that I am going to use F11. Now you can see the first step, value 1 will be assigned with a memory address 30. So that is captured in which register? R0. Now content of R0 gets copied into register R1. So this entire stuff will get copied into register R1. Same. Again you can see for value 2 the address assigned is 38. So at 38 memory location the next number is stored, this one. Now it will get copied into register R3. You can see here. Yes. Now the next step is add R2 and R6, R4. The content of R2, R4 get added and the result is in R6. Now you can see that at R6 it is 666. Okay. Now you can see that in R5 the content of R5 are 000. Now after execution of this step the content of R5 will get changed. The content of R1 gets added with content of R3. You can see here. Okay. So now the result addition is done and the results are available in register R5 and register R6. Now this result we have to store at variable result. Variable result, now this instruction is very much similar to this instruction. Here the variable result have been assigned with memory, some memory address, and that memory address is captured here in register R0. So now the memory address is 40000. Now this memory address, now the content of R5 is stored to memory location pointed by R0. So exactly opposite to this instruction. So the content of R5 will get stored at memory location 4000, which is assigned for is equal to result. And similarly the content of R6 to R0 plus 4. Now we will see the result at memory location 40000. For that go to view, then memory 3. You can write down the address 0 1 2 3 4 5 6 and 7. Enter. Now you can see the result 444666. If you want to see the numbers, I mean it was 5 6 1 2 3 4 5 6 7 and 8. You can see the first number is 1 1, so it requires 0 1 2 3 4 5 6 7. So it require 0 to 7, I mean 8 memory locations. The next number will start at 38, so it will start from 38, which we have seen earlier. So students, take this screenshot of this. I want this result also. Hope you understood the program execution. Thank you.